Welcome to my channel. If you like my videos, then kindly subscribe, like and watch. Thank you.
Bismillahirrahmanirrahim. Welcome back. Problem 9.9. The statement of problem is that knowing that beam AB is a W wide flange beam of 130 by 23.8 roll shaped, P is equal to 50 kilonewton, length is equal to 1.25 and E is 200 gigapascal. So determine the slope at A and deflection at C. So we are going to find the deflection slope at A. Clear? We have to find this, and due to this load P, there the beam will deflect like this. Here. So this is the axis of the beam. So you have to determine this deflection, which is equal to YC, and you have to find that. Clear? So let's start with the solution. Okay, so first of all you have this beam. Clear? Let me clear it. You have this beam, the loading is shown over here, so you have to determine the reaction forces RA and RB. So you can see the load is there is a point A and point B. The load is symmetrical, so we will use the symmetrical boundary condition. Use symmetrical boundary condition at C. So you can see this load, the P will be divided by 2. So reaction force at RA is equal to RB, and that will be equal to P by 2. Now we have find out the reaction forces, then we will move toward the for finding the moment for this beam. As from our previous knowledge, we have this equation, that equation EI into d square y over dx square is equal to moment. So we will interested to find out the moment. So you can again see that we have to find the slope at A and deflection at point C. So we will section the beam over here. So when you take the section of beam, so there will be a reaction force RA there, and let this distance where we want to section it is X here. So this distance is X. So when you cut the beam over here, so there will be a shear force and bending moment, reaction bending moment. Clear? Let this point is J. Clear? So now we will find the moment equation for this. So for finding moment, we will take sum of all moment about point J is equal to 0, taking counterclockwise as positive. So you can see at point J there is a reaction moment which is counterclockwise, so it will be M, and now there is a reaction force which is creating a clockwise rotation, and that will be equal to RA into X. Since this is producing a clockwise, so it will be minus, so their sum must be equal to 0. So what we get is that moment is equal to RA into X. Now we have RA which is equal to P by 2, so it will be P X over 2. So we have moment which is equal to Px over 2. Now we will use this equation in this. Let this is equation number 1 in equation 1. So let this is equation number 2. So putting 2 in 1, we will get EI into d square y over dx square is equal to px over 2. Now we will integrate it. Integrating it, so we will get ei into dy by dx, and this will become equal to px square over 4. It will be px square over 4 plus there is a constant of integration which is equal to c1. Now you have to again integrate it. Integrate it will give you ei into y is equal to px cube over 12. So px cube over 12 plus c1 into x plus c2. Now these are the equation. From this equation, this is equation number 3, this is equation number 4. From equation number 3 we can find out the slope, and from equation 4 we can find out the deflection. But here c1 and c2 are constant of integration and they are unknown, and they can be found by using boundary condition. So I will show you the boundary condition. So we will use the boundary condition that at x is equal to 0 we have y is equal to 0. We will use this boundary condition. And second, if I draw, it will deflect the beam like this. So at point C, this is point C, clear? So at point C, which is at x is equal to L by 2, the slope will be equal to 0, because if you draw a tangent line, so the slope at C will be equal to 0. So we will use these two boundary conditions in order to calculate C1 and C2. So first boundary condition is that at x is equal to 0, deflection is equal to 0. And second boundary condition is that at x is equal to L by 2, because at point C length is L by 2. We have theta is equal to 0. So let's move and put this boundary condition in equation 3 and 4. So at x is equal to 0, y is equal to 0. So you have to put in equation 4. Put in equation 4. So x is equal to 0. So this term will be 0, and this x term will be 0, and y is equal to 0. So we will get C2 is equal to 0. Clear? Now at x is equal to L by 2, theta will be equal to 0. So put it in equation 3. This is equation number 3. So when you put x is equal to 0, y is equal to so not at x is equal to L by 2. At x is equal to L by 2 dy by d. So this term will be 0 there, and this will be equal to p into x will be L by 2 whole square divided by 4 plus c1. Clear? So c1 will be equal to minus 1 over 16 pl square. So now you have both the value of C1 and C2. You can put in equation number 3 and 4. So let me put it. When you put C1 is equal to this, so you will get the equation 3 become equal to EI into dy by dx is equal to theta. Clear? Let me write it clear. Dy by dx is equal to theta, and this will be equal to px square over 4 minus 1 over 16 PL square. Now you can divide both sides by EI, so you will get theta is equal to EI, theta is equal to 1 over EI into px square over 4 minus 1 over 16 PL square. Now you can take something that is common in between these two. So again this theta will become equal to PL over 16 EI here into 4x square minus L square. Right, this is L square. When you multiply it will give you the same thing, right? This will be px square over px square over 4. This will be the same thing, and you can also you can do it. Now you can also put the value of C1 is this and C2 is equal to 0. So equation 4 will be EI into Y is equal to px cube over 12 minus 1 over 16 PL square into x. Clear? And when you divide it both sides by EI, so you will get deflection or equation of elastic curve as 1 over EI into px cube over 12 minus PL square x over 16. Clear? And if you further simplify it, you will get y is equal to PL over 48 EI, clear, into 4 x cube minus 3L square. 3L square into x. So this is equation of elastic curve. Now we were asked in first part you have to find slope at A. Clear? And in part B we are given deflection at point C. I will show you slope at point A, which is at x is equal to 0, and deflection at point C, which is at x is equal to L by 2. So at x is equal to 0 you have to find the slope, and at x is equal to L by 2 you have to find the deflection. So this is the equation of slope and this is equation of deflection. So first we will find theta A at x is equal to 0. So when you put x is equal to 0 in this equation, so this term will be 0. Clear? This will be minus L square, so it will be equal to, theta will be equal to minus PL cube over 16 EI. Clear? So negative sign means clockwise direction. So deflection will be like this. If the beam deflection was like this, this is point B, this is point A, sorry, beam slope. So this is theta A. Clear? Now the part B was you have to find the deflection at point C, which is at x is equal to L by 2. So you will put it in this equation Clear? So when you put at x is equal to L by 2 in this equation, so y will become equal to PL over 48 EI. Again, this will be equal to 4 times into L by 2 whole cube minus 3 L square into L by 2. So when you simplify it, this YC will become equal to PL cube over minus PL cube over 48 EI. Clear? Okay. So negative sign means downward movement, that is initial axis was this, so this will be YC. Clear? Okay. Now we will find their numerical value as well. We were given that load P is equal to 50 kilonewton, so 50 into 10 raised to power 3 Newton. E was given as 200 gigapascal, so 200 into 10 raised to power 9 Pascal. Clear? You have L is also given, which is 1.25 meter. Clear? So you have PE, you do not have I, and it is also given in question W 130 by 23.8. So if you go to the appendix of the book, you can see that this is 130 into 23.8 and its value of moment of inertia is given, which is 8.99 or 8.88 into 10 raised to power 6. So you have to take the value from that table. So I is equal to 8.80 into 10 raised to power 6 millimeter 4, and if you convert it into meter, it will be equal to 8.80 into 10 raised to power minus 6 meter 4. Now you can put the value, when you put all the value in this equation, so theta A is equal to minus 50 into 10 raised to power 3 into L is 1.25 whole cube. Let me check the thing. Whole cube divided by 16 into 200 into 10 raised to power 9 into I is 8.80 into 10 raised to power minus 6. So when you calculate this, okay, I think there is a mistake, you can check it. This theta A is equal to this is cube, PL cube, okay, PL cube, okay. So you can put the value and you will get theta A is equal to minus 2.77 into 10 raised to power minus 3 radian. Or you can also say it is, if you do not want to write minus, so it will be clockwise, theta will be clockwise. Similarly, you can also put the value of P, L, E and I. So you will get YC is equal to minus 1.15 into 10 raised to power minus 3 meter, or YC will be equal to 1.15 millimeter, and since it is negative, so it means downward. I hope you have learned from this video, and again you have a clear idea about how to use the equation of elastic curve in order to find the slope and deflection. Thank you for watching.